Okay, let's go ahead and try a problem using integration by parts. The formula for integration by parts is the following. The integral of u dv is equal to uv minus the integral v du. So what we need to do is we need to find an appropriate u and also an appropriate dv, and then we'll just plug it into the formula. Now, how do you pick these? Well, sometimes you just play around with them a little bit, but what I'm going to say to do is for the u, try to pick something that's easy to differentiate and reduces in form, so it becomes more simple. So usually when we're picking u, we want something that is more simple, or becomes more simple upon differentiation. So I'm going to let u be equal to, now this is the inside, so I got to pick, and I'm gonna let u be equal to this guy right here, so just x. So when we differentiate, when we get du, that's just equal to dx. Now, why would we want to differentiate? Well, if you notice back over here, we need du and we need u. So I have what u is equal to, and now I have what du is equal to. Okay, now dv is what's remaining. So dv is this whole thing right here. So dv is going to be equal to e to the negative 3x dx. Now the choice for dv, your choice for dv, well, again, it's what's remaining, but also this guy should be pretty easy to integrate. So or it should be easily known or well known, or there should be some formula for it. So if we want to work backward, okay, if we take the integral of both sides, so if we find the antiderivative of both sides, well, if you think about it like this, okay, so v, right, the integral of this is v, and now working backward on this guy, it is e to the negative 3x over negative 3, and you can check that. You can check that using substitution. Okay, so now we've got what dv was equal to. I'm going to erase these so that you can see exactly what equal to. dv was equal to this, and then v is now equal to that because of what we originally set dv to be equal to. So now we're going to go ahead and plug things in. So the integral of u dv that integral is equal to u times v. Well, u is x, v is this guy, minus the integral of v, which again is this guy, du, and du is dx. So I've done my substitution here. Substitute my pieces in for my integration by parts. Well, now I want to try to determine this guy right here. So what do we have? Well, this is x e to the negative 3x over negative 3 still. I'm going to move this negative 3 out, so this will be positive 1/3 integral e to the negative 3x dx, just like that. Okay, now what is the integral? What is the antiderivative of this? Well, we already know what the antiderivative is. It's this guy right here. So this will be equal to x e to the negative 3x over negative 3 plus 1/3 times e to the negative 3x over negative 3, and then of course we have that constant of integration. So what do we have here? Well, I'm going to pull out e to the negative 3x over negative 3. So I'm going to get e to the negative 3x over negative 3 multiplied by, now what's left on this guy is just x, and on this guy it's 1/3. And of course plus our constant of integration still left there at the end. Okay, so that looks right, but now what we can do is we can go ahead and we can check, verify that if we differentiate our answer here, if we differentiate this guy, we should come up with our original guy here in the middle, right? We should come up with this guy. So let's take this right here, okay, and let's differentiate it. So this is our check. Okay, so when we differentiate that, we can do one of two things. We can multiply this together first and then differentiate it, or we can just leave it the way it is. I'm going to leave it the way it is, but I'm going to bring this into both these. So the derivative of this last guy is 0, so we're not going to worry about the constant. Let's worry about differentiating this guy right here. So we have to use the product rule. So the derivative of the first is negative 3 e to the negative 3x over negative 3 times the second plus the derivative of the second, which is just 1, times the first. So now what I'm going to do is simplify a little bit here. So these guys are gone, and I'm left with this right here is going to be x times e to the negative 3x plus 1/3 times e to the negative 3x, which is e to the negative 3x over 3, plus 1 times this, which is going to be a negative e to the negative 3x over 3, right? Because this negative, I brought it up front. And notice now that this guy and this guy cancel, and this is equal to just x e to the negative 3x. So sure enough, when I differentiate this guy right here, I end up with this guy up here in the top. And that's what I should get. So my recommendation for you is that when you work through your integrals, go back and differentiate them to make sure that you come back to the original integrand.